Next, I will show how to apply the one-mean t procedure to test a statistical claim about a population mean. Consider the following example. An incubation period is a time between when you contract a virus and when your symptoms start. Assume that the population of incubation periods for a novel coronavirus is normally distributed. By surveying randomly selected local hospitals, a researcher was able to obtain the following sample of incubation periods of 10 patients: 6, 2, 4, 3, 3, 7, 5, 8, 5, and 7 days. At 5% significance level, test the claim that the average incubation period of the novel coronavirus is less than 6 days. First, let's note that the average of the sample is 5. And since the population standard deviation is not given, we compute the sample standard deviation instead. It is equal to. Now, let's identify the statistical claim that needs to be tested. The claim is that the average incubation period of the novel coronavirus is less than 6 days. The keyword average suggests that the claim is about the parameter mu, so we can symbolically express the claim as mu less than 6. Since the claim is about the population mean and the standard deviation is unknown, we will use the one-mean t procedure. Before we begin the one-mean t procedure, let's check if all necessary assumptions are satisfied. The sample must be assumed simple random. If not, then the results of the test are invalid. The central limit theorem must be applicable, so either the population must be normal or the sample size must be greater than 30. In our case, the population is given to be normal. The population standard deviation is unknown, but we found the sample standard deviation as equals 2. We will use the following template to perform the hypothesis testing. In step 1, we will set up the hypothesis. In step 2, we will identify the significance level. In step 3, we will find the test statistic using the formula. In step 4, we will perform either the critical value approach or p-value approach to test the claim. In step 5, we will draw the conclusion, and finally, in step 6, we will interpret the results. Since our claim, mu less than 6, is in the form of an inequality, we are going to set it up as an alternative hypothesis. Therefore, the null hypothesis, which is always in the form of an equation, must be mu equals 6. So the test is left-tailed. Step 1 is complete. The significance level can always be found in the text of the problem. In our case, it is 5%. Step 2 is complete. The test statistic can be computed using the formula. In our case, the test statistic T0 is equal to negative 1.58. Step 3 is complete. Next, we will test the hypothesis using two different approaches, the critical value and the p-value. In the critical value approach, we construct the rejection region. In this approach, we need to know the significance level alpha and the type of the test. We draw the rejection region under the student t probability density curve with 9 degrees of freedom, according to the type of the test. So left tail test will have the rejection region in the left tail. The region must have the area equal to the significance level 5%. The right boundary of the region is the critical value negative t 0.05, which is equal to negative 1.833. So the entire region can be described as the values to the left of negative 1.833. In p-value approach, we compute the p-value. In this approach, we need to know the test statistic and the type of the test. We find the p-value using the student t probability density curve with 9 degrees of freedom, according to the type of the test. So in a left-tailed test, the p-value is the area to the left of the test statistic. Symbolically, it can be expressed as the probability of t being less than negative 1.833. 1.58, which is equal to 0.074. Next, we're going to decide whether to reject or not reject the null hypothesis. In the critical value approach, we must check whether the test statistic is in the rejection region or not. Our test statistic is -1.58, and it is to the right of the critical value, -1.833. Thus, it is not in the rejection region. In the p-value approach, we must check whether the p-value is less than the significance level or not. Our p-value is 0.074, and it is greater than alpha. Both tests suggest that we do not reject the null hypothesis in favor of the alternative. Next, we are going to interpret the results. Interpretation. Under 5% significance level, we do not have sufficient evidence to suggest that the mean incubation period is less than 6 days. The hypothesis test is complete. I just showed how to apply the one mean t procedure to test a statistical claim about a population mean when the population standard deviation is not given.